So I hope you're okay. I mean, probably many of you would be expecting a holiday um, tomorrow or Wednesday because the typhoon is coming. Uh, at least for my kids, are very happy with they have no class tomorrow and Wednesday. But I guess for us, we're adults. Probably we still have to take classes. But I don't know. Um, but you don't have. I mean, most of you don't have kids, I suppose. Then you don't have this problem. I mean, I have to take care of them, so it's a troublesome period. But I guess it's happy always when you don't have kid when you have holiday. But now, like me, I mean, it's always a pain. But so what's the goal today? Is we will be finishing off the probability slides. That means that I will release assignment 1, so you can work on it, and I will also release self-checking quiz 2, so you can work on it as well. And I think the assignment is very similar to the example that I give in the class. So basically, you are working again on those ideas, so make sure that you are familiar with those again. And after that, we will talk about random variable. Okay, we will soon do that. But oh, what happened? So let's quickly review what we have done. I guess last class we cover all the way up to counting, right? So counting, we cover up to here, right? Am I right, right? Am I right? Right. So, but anyway, so let us go from the beginning and again, and then we are going to recall, because I think it's such a long time. I mean, you don't remember even where we stopped last time. So it's good to review and then with some idea what would be there. So the first thing to do is start from the probability you learn in the high school, right? The probability in high school is just a classical idea of with frequency, right? You just potentially, you can repeat something and you repeat many times, and then you look at the ratio as a fraction, how many times one thing appear over the others, right? And then that will become idea, because why does it make sense? Because we're expecting something can be repeated many times, and if you do enough experiment, the experiment should be reflecting what's going on there if you actually do the next one, right? Because everything is the same. But the problem of this is, what happens if things can't be repeated, right? I mean, there's something like you roll a die, toss a coin. It's simple enough. You can imagine you can roll a die, toss a coin. What about typhoon, right? The thing we have the cyclone tomorrow. What expect? Is it something similar happened in the past? Can guide us what's going to do, or is there any scientific knowledge that can guide us to tell how likely that we're hit by the typhoon and how, right? Then the problem is unclear because every typhoon is different, right? Everything is different. So how can we say about probability, right? It's difficult to say that, right? So that's the reason why we have to go from the classical idea of a experiment you can repeat it to the axiomatic definition of probability, where you have to make the minimum assumption on what can be done there, and then you add the knowledge, right? So that is the axiomatic definition. And we start from the fact that the first axiom say it must be between 0 to 1 to remind you that it need not be, say, odd ratio, which we also learned is from 0 to infinity, right? And the second one is the sample space, right? The sample space must be 1. So it implies that we know everything about what might happen, right? And the third thing is the thing that gives us the most important bite, is that the probability of a whole will be sum of the probability of its parts, right? So basically, the idea about divide and conquer, right? If you look at the whole thing, you can cut it into several pieces, you add them together, right? So remember, the example would be, probably even number would be probabilities of 2, 4, and 6 add up together, right? So that would be the idea behind. And this example illustrates why this is important, because, say, especially the bullet point, the fourth bullet point, right? we know axiom 2 says this is 1, and axiom 3 said sample space is equal to probability of each outcome. But the fourth bullet point is a key because it tells us that when we assume, which from engineering perspective or from data, right, may not be able to repeat many times, but suppose it's the case, right, from data or from the engineering, we know the die is perfect or fair or symmetric, then each probability is equally likely, then we can get 1/6, right? But if our engineer tells us there's some defect in the die, which makes, say, 1 twice likely than all other numbers, we can also calculate that, right? So that means that we can have some engineering or some observations can update or can tell us what this probability is, and that allow us to use our knowledge to write probability, right? Which is not possible when you have random experiment because you're able to repeat many things, right? Because how able you can repeat typhoon, right? Each time you need, right? But you can repeat something more similar or easier, right? You divide things into smaller parts, right? So that is how human progress is like we make things easier to analyze, right? We divide them one by one. And that same goes to all the complement rule, right? Because it's how our knowledge comes from, right? Our knowledge may not come from itself, but can come from its complement, right? For example, we know how likely the die is going to be 6, but we don't know 1 up to 5, but that is the idea that how you can extend the knowledge from one over the others, okay? Same for the addition rule, right? Addition rule only allow us to say what happened if I look at the union of 2 events, right? But they are no longer mutually exclusive, right? Because axiom 3 tells us if A union B, right? If A and B are mutually exclusive, we just add them up, right? But if they're not, then you have to subtract its intercept. So that tells us how you can create union, right? Because intercept is sometimes easy to calculate as well, right? And the next one is something you know very well because the total probability rule we say is the A, right? The couple 2 part is A with B and A without B, and this is what we use when we do base rule, right? At the denominator, right? And odd ratio we know very well, right? Because this is very clearly with the betting, right? So you go casino. If the casino is competitive, is fair, the odd you see is the inverse of the odd ratio, right? So that is how you get that part. And after that, we talk about conditional probability, which is something that the most important part is if you know something happened, how you update your probability directly, right? So if you know A is probably A, but now you know B, then what happened to that? Okay. Actually, this is also updating, right? But we start from scratch, right? We don't update anything, but just say, now I know B has also happened, right? Just like the idea of the rolling a die, right? Now I know large has happened. So the sample space actually shrinks, right? So that's why it's like this, okay? That's why it's like this formula here, okay? And after that, we just flip the multiplication rule, okay? And that gives you from the conditional probability, right? You multiply the denominator per B, then you give you the numerator. So this is the formula there. And you can combine these 2 rules, give us what we want, okay? So, and the very last is the independence. And you can notice that there is something very important is the last formula, which we will use actually heavily for the second half semester. The probability of the intercept is going to be the product of the 2, okay? It will be true if they're independent. And why we need that is because that's what we assume you will see very soon as well, is when we collect data, right? We saw something, 2 observations, A and B, right? 2 observations, and we want to say when we collect data is independent, we can treat it as a product of them, okay? That would help us to simplify our calculation a lot. If we don't have this structure, then all the calculations are very complicated, okay? So that's will be the underlying thing that we will do for the second half of our course. So just like we observe two outcomes, or we collect data, right, from two individuals, as long as the way we collect a sample is independent, so we can treat them as two different draw from the population. And the way, because of this, all our calculation will be much easier because of this idea. So this is something that we can't really check in general, but this is what we assume. And we assume this, then make our calculation all easier, okay? So that's why we have to talk about this at this moment. And so we go to the very important thing, that is the very last thing we want to review, and I want to review in more detail a little bit for this one, because this one is the key of one of the key things I want you to remember from this class. Of course, one is regression, the other is Bayes rule. They are all the most two important things I would say in this whole course. Let me say again what's Bayes theorem. Bayes theorem is this formula, but of course the formula is nothing very deep. You can find it anywhere, but the main important part is the right-hand side, the prior, and the left-hand side, the posterior. So the prior is before you observe something or the initial belief of what you think is true or given the existing knowledge. Now this probably A, right? That what A happened. And if you observe B, so you want to update our probability of A with A given B, right? B can be considered as new information, news, new knowledge. That's what happened, right? That's what happened. Our initial belief of, say, what happened, how likely we have high frequency number 8 tomorrow, right? And we have some idea, but now as time progresses, more satellite image, then you update this one, right? Now it's pretty much sure. Tomorrow you have high frequency number 3, right? And very soon with 8 as well, right? Then how do we do that? It's just based on this formula, right? Actually, even the observatory supercomputer, they also follow this rule, okay? More or less. Maybe there's something, some computer science will tell you maybe some different about this rule, but more or less will be following this idea. But look at this, okay, how do we update? The update you can see is by multiplying through this fraction, right? A fraction. Of course, if this fraction is more than 1, which means that A is revised upward, right? A more likely. If A is less than 1, it's less likely, right? And the worst case is 0, right? And this fraction, right? The worst case, the best case is 1, right? Go only at most it go up to 1, right? Can't be more than 1, okay? And so the very first thing we say is if A and B are independent, right? Probably B given A just probably B. So this must be 1, right? So if A and B are not related at all, then you don't change after observing B. So left-hand side, right-hand side, the same thing, right? Because the fraction, the red one is 1, okay? Because nothing new is learned, right? Tell you the A, the B, the probability is the same. So the fraction must be, the red fraction must be 1, okay? Now, consider the other case, which is you see A, if A is true, you never see B, right? Then you see B, then you say A cannot be happen, right? Let me repeat the statement. If you see A, B will never happen, right? Then if you actually see B, then A would never be true. For example, A may be a case of maybe a murderer, right? Probably he is the murderer, okay? And B will be, say, he actually is in another country at the night that the murder happened, right? Unless he's a superpower, right? He can kill other people from other country, right? So the probability B given A will be 0, right? So you update, it will be 0, right? So he's a murderer. How likely is the other country? No, right? He can't be other country. He's a murderer, right? So this will be 0. So update will be 0. You see that? Right? So, and of course, you can see if A and B are closely related, right? This fraction the red flag should be more than 1, right? Of course, the best you can do is become 1 over probability A, that cancel out, that become 1, right? The best case scenario, okay? But that is what it is, okay? But let us go to the example again, because I would like to point out this very important example, because that helps us to understand what's going on. Let's see the example again. I know probably you have known this very well, but just to be safe, okay? So this example, we have 2 bets, bet A and bet B. A has 4 white and 1 green. The bet B has 1 white and 1 green, okay? It's very clear. So the thing is to close your eye to draw a bet at random, and the ball is drawn randomly from the bet. So what do we learn if this is a white ball? Just to remind you why we care about bet and ball. So you can imagine that what we're doing, we're predicting the economy from stock market performance. Okay? What we're doing is if A and B was what? A is good economy. B is bad economy. Okay? In good economy, stock market is more likely to go up than down. So white is the stock market goes up. Green is stock market goes down. Okay? So now what we have is we have a white ball, stock market goes up. How likely that the economy is going to be good? Right? So that is how we are predicting, and that's why you learn in the macroeconomics. I think in the 1040, so you have to study, saying that the stock market is what we call the leading indicator for the economy, right? Because how the stock market moves is actually tell, and this is application for those. Okay? It's very important. Or you can think about this is also the auditing example, right? You are looking at the client, and the client may be doing the truthful reporting or the false reporting, which is A and B. If true reporting, you get the right amount that stated in the statement, right? You may get the wrong thing, right? It's inconsistent with his report, so you want to check. So that is the same idea. If you get a wrong report or the true report, then how you update it, right? So that's the same idea here. So let me, the question would be this, right? If you have a white ball, how likely is this one, right? So the idea is is asking the probability, right, of A, okay, given is white. So that is the question, right? Or B given is white, right? So if you don't really care, then you just apply the formula directly, right? So just maybe, right? The formula, you put the denominator down there, and then what you're updating is whether you A or not, right? And just swap this guy. So this is the formula there. And how likely is the A is already in the prior, which is 1/2, right? This 1/2, because this is initially we know the bet is chosen at random, right? We have no idea. Okay, that's how you do when you have no idea what's going on. And this is we know already. If good economy, then will be 4 over 5 will be likely. So the only thing we look up is the denominator. But the denominator is just white. White is considered as 2 cases: white under A and white under B. Right? So you just calculate white under A and white under B. How do you do that? Use multiplication rule, right? If you multiply 4, 5 by 1/2, then it's white under A, and 1/2 times 1/2 is white under B, right? So that is how we get the formula in the next slide, right? Or if you don't want that, where's my graph here? We don't have a graph here, but it's like here, right? A and B, right? I should have drawn the graph here, but this is, right, A and B. This is 1/2, 1/2, right? And after this, you have white and green, which is 4 over 5, 1 over 5, right? 1 over 2, 1 over 2, right? So basically what you're doing is this edge is called X, right? and this edge we call y is x over x plus y, right? To be the probability y given a, right? This is what we have already. Okay. So the next one that we want to talk about is the this infection. Okay, because you do something similar for your assignment, so I just make sure that you know what's going on again. Okay, very carefully, because as I said, the base rule is the most important thing for this. So I will be very quick because I know we have covered this already. So I just try to be as fast as I can. So this question is, let me write down in the why is, I don't know, maybe I just use the question here. It's like, is this tree, right? So in the general public, in the prior, it's like this one, right? So this is, without doing any tests, this is what we know. You pick up a random person, 40% of them has disease, so you pick a random guy, 0.4 is your assignment, how likely that he is disease or not. So the question would be, okay, now I have the guy is actually infected, right? Which is your samples, if you do the test, there are only 2 cases, you are infected or you're not, right? So, but there are 2 scenarios, actually you are the guy infected or not infected, right? Positive or negative, okay? So what it means is, if you have a guy who is positive test result, this is the new sample space. Suppose called this X, this is called Y, right? So if I want to ask how likely that you are infected with yes, right? Given you're positive, right? Then it just very simply just X over X plus Y. And X is just 0.4 times 0.8, right? And Y with 0.4 times 0.6, because this is 0.4 and this is 0.6, right? So that's how you do the calculation, right? So just very simple, because strength, so just the first branches over the first and the third one, okay? And more importantly, of course, I hope you would be able to do your calculation in your assignment. What is interesting is here, where if you do a test, okay, your probability, if positive, will be rise up 40%, from 0.4 to 0.57. If negative, you are dropping from 0.4 to 0.18, right? That means that once you do it, of course, you go up and down, right? But you go down more than you go up, right? Because go down, absolute value, you go up by 20, right? And go up, you just by 17, right? So it means that if you have positive and a negative, what's the probability, right? Suppose the first one is positive, the next one negative. What do we learn? So suppose the first one is positive, so you have 57%, but that will become your new prior, right? So you, when you update it, you apply the same formula again, then actually negative will reduce by half, right? So you, from first one is 57, and then the negative, you give you 28, okay? Because 37 by half, 28 something, okay? So it's not 0.4, right? Because positive is initially is 0.4, positive go up by 0.37, but negative you drop more than that is 0.3, because negative carry more information than positive, right? Is that clear? So it's, but if you are negative first and positive again, okay, it also doesn't go back to 40, right? Because first one 40, negative give you 18, right? And you go up again, it's 20 something, okay? Because you go up by 40%, okay, it's positive. So it doesn't go back to the original position, right? So negative news and positive news are not symmetric, right? So that's why when you go up and down, it's not the same thing, okay? So go back to the story, right? You want to learn the good news first or bad news first can be not the same, right? or better not to tell me, right? It's not the same thing. So if you give me an option, maybe I'm actually not very happy. But anyway, now let's get to counting. And you may ask why we need that, because we need that for the next set of slides. And we need to do some calculation. And if you learn math from computer science, and that's the first class called discrete math. That's one discrete math, because that will, the very first few classes they learn this combinatorics, because they do the counting. That is very important. If you go to computer science, this is the first few classes they learn. So the thing here is the counting. To start with a mission, we have two tasks. And suppose each task is your different way to do it. Okay, the N1 way to do the first task, the N2 way to do the second one. Okay, how many different ways to do it? It's just N1 times N2. Why? Because for each way to do the first one, and the N2 way to do the second one. Okay, there's N1 to do it, it's add up N2 N1 times. So basically it's add, multiply, right? Or if you can't visualize this, you can think about this in a table, as I write it here. You can imagine that this is task 1, this is task 2, right? And task 1 have 1 up to N1 way, and N2 task 2 you have 1 up to N2 way. And in this table, each entry will represent how you do it, right? For this one, maybe the first way to do it for first task, and first way to do the second task, right? So you just count how many entries in this table is how many ways you can do it. We just N1 times N2, right? Because the N1 rows and N2 columns multiply. So you can generalize this concept to general idea, right? Where if you have k tasks and each task have ni way to do it, you just multiply a different way. Okay? So let me give an example, because this is very abstract. A concrete one is motivated by my experience in CHK. Probably I mentioned it already. So I have this in the canteen, I think 20 years ago. And why I care about that? Because I have no money. I mean, there's only menu I can eat. Okay. And of course, I don't want the same menu every day. So I just try to see what kind of menu I can eat without repeating myself, right? So here we have two types of dishes, either rice or noodle. And there's 3 types of meat. This is pork, beef, and chicken, the 3 types. And sauces, we have 3 types of sauce. Black sauce is the pepper. The white is the mushroom, right? Red is the curry, right? And there are how many different ways of meals. And we have 3 tasks, right? And each task, the first task have 2 ways to do it. Second task have 3, and last have 3, right? So it's 2 times 3 times 3, right? So 80. So that means that I can have this same thing, right? We do not have same thing, right? Until I have half a month, right? At least half a month, I only not to repeat myself. So pretty happy, right? Even though you don't have a lot of money in your pocket, that's how I survive. So another example, more realistic one, is like maybe more applicable, is talking about rolling die, right? And I guess it's not too complicated to see how I apply this, okay? I consider a case of rolling die twice, okay? And I only care about the sum, okay? And I want to know probably less than 12. And of course, first thing you notice, roll a die twice, okay? Roll once, you have 6 outcomes. Roll die second time, 6 outcomes. So how much of the outcome you can set is 6 times 6 is 36, right? And you count how many outcomes is less than 12, can be a lot. But let's do the complement rule. How many outcomes that exactly 12? Only 1. You got 6, and 6 is 12, right? So you just calculate the probability of exactly 12 is 1 over 36, and complement rule tell us is 1 minus from that, that's 35 over 36. Right? So that is rather easy, right? Rather than just calculate everything, okay? Now the next, I think it's more fun. It's called permutation. This is what we call lining up on the line. So consider we have n different balls, okay, and we want to put them aligned. When we put a line, that means that who's the first, different who's the second, right? So that means that with n balls and put them all together. Look at the first ball, first slot, the first slot, first spot, and n different ball can fill in. So the n different way to do it. But what about the second slot? Remember, once you fill the first slot, there's one less. So the n minus 1 available. So it's n times n minus 1. And go to the first spot. You use up the 2 already. So that means that it's n minus 2 to get to it. So it's n times n minus 1 times n minus 2, n minus 3, n minus 4. Last one is n choice. So that is called n factorial. The factorial is always calculated. You actually need this, it's multiplied many times. And of course, you need not take out all the balls, right? You can take out, say, 2 balls or 3 balls and line up this time, right? So that's why it's called n balls out of. So out of n, right? So that means that suppose I have n balls, but I only need to do 2, right? So the first one is n and times n minus 1. Okay. So that means that I would have n times n minus 1, but n minus r plus 1 because it starts from 0, 0, 1. R minus 1. That means that it's n factorial n minus r factorial. This we call n r, which if you learn n2, the math in Hong Kong is free. Okay. And probably, okay, why do we learn to do this? Okay. If you go on holiday, you always need this. Why? Imagine behind me is a landmark, maybe Fuji Mountain or whatever building you can imagine. Okay. So you go to photo with your friend, right? We do the first take a picture, right? You do a selfie, right? Okay. If you go by yourself, there's only one way to do it. Ding, ding, right? Suppose if you're your friend, right? Then you take one picture. What happened? Not done yet, right? Then wow, it happened. Right? Then you have 2 ways to do it, right? Because the first spot, 2 person to do it. Second spot with 1 way. What happens if you go with not by your friend, but 2 of your friends? How many ways to take picture? First slot, you have 3, yes. Second one, 2, that's 3 times 2 times 1. Right? Suppose 4 friends. How many ways to take it? 24, right? Suppose each photo will take you at least 1 second to pass, right? You have almost 1 minute, half a minute to do it. Right? But of course, usually 1 picture will at least take 3 seconds. How many seconds? 24 times 3, almost like a minute or so. Right? And then you can see if you have 5, already how many minutes you have? 120, right? Or 2 minutes, right? So that's why you can't get too many people to go to home. Otherwise, only by taking picture then do it over time. Okay, so that is very important. Remember, when you take pictures, don't forget to count the number, right? Otherwise, you forget all the ordering, right? But I guess these days you don't have seen in the old days you have the photo booth, you go there and that's how they take just swap in here and there. Right? And then you have some sticker, right? So you have a different sticker and then you can have more fun. Okay. So the next one, we'll talk about this in a break. It's also motivated by my life in US. Okay. And probably you may not know this. Actually, our canteen is not very expensive. But if you go to US, the canteen is so very expensive. At least for my salary or for my living expense, it's like I think 10 years ago we go to a campus food. Even 10 years ago, the cheapest one is like $10 US dollar. Cheapest. maybe just a pizza, 2 pizza. But of course, as a student, I don't have enough money. So what I'm going to do is to eat fast food. Fast food in the US especially. So either McDonald's or Subway. I think this is supposed to be and Subway is not expensive. It's $5. So actually, $2 or $3 is not that expensive. Before now, the inflation gets very expensive. But at those days, very cheap. So that's what I do, right? Because no money, so don't want to repeat, right? So just count how many ways to figure out. Okay. So of course, I think it's simple, but actually it's more choices you can do in Subway. But the Subway, I remember that is what happened is they are freedom quite bad. But I think if you go to the bigger store, you have more choices. But that one is small store. Next to the campus, you have 1 hour free bread. Okay, why Italian home bread? But of course, more. It's really simple. And your 2 ingredient, you can choose 2 ingredient out of 6. Veggie, beef, egg melt, chicken, tuna, and tomato. Okay. And the question is how many ways to do it? Okay. Because I don't want to repeat, right? And do look at the way I do this. The way to do the sandwich is to put the ingredient one over the other, right? So that means that because of say tuna is a little bit juicy, some water, oil. So you put the veggie at the bottom and the tuna at the top is different from tuna at the top and vegetable at the bottom. So it's question one the same, not the same thing, right? So of course it's the same. Then someone will talk after the break. It's called combination, but combination we care about it all. Okay. So that means that all that matters. Okay, the sandwich. So let's do the how many way I can have the sandwich. So first you choose the bread, so there's nothing you can do. There's 3 different ways. Okay. And now at the sandwich, I have the order method, right? How I rank them, put them in order. So I have the 6 ingredient. I choose 2. That is 6P2, right? That if you don't like the P, just like you have 2 slots there, right? The first slot, the top, you can put 6 ingredient. The bottom, you can put 5, right? Because you don't allow tuna and tuna, not double tuna, right? You only have 2 different ingredients. So that means that you have 3 times 6 times P 6P2, right? So means 60. So good news, right? Because 90 means 30 is like 3 months, right? So 3 months, I don't have to repeat myself, right? Do you remember I didn't even add drinks, right? I didn't add in the US there are a lot of dessert like brownies and cookies. I add a little bit there. Then it will be like whole year without drinking, right? Suppose I have 4 drinks, right? Suppose simple, very simple, just 4 different things. Already 1 year without drinking. We're very happy, right? And so that will be the example there. Okay, we'll talk about combination at the end, and then we will be done for this set of slides. So in the meanwhile, let me go to the U reply. So we have a break of 15 minutes. Something. I want to talk about. They said it's called the airport code. 24 hours. 40 hours. Tuesday. I haven't got that. Why did I escape? And they say, I can't come back, sorry. So hope you are okay. So let's continue that. See how well you're doing. If you haven't fill in, please fill in, because this also kind of look at how you perform, and we count your grade for your attendance or participation. Right? It's not one-to-one, but we will just try to see how well you're doing and just loosely map you into the branches. Okay, to the grading. Okay, for evaluation, participation. So, yeah, I'm very happy. Is it very cold? Do I need to, is it very cold? But I don't know if I can switch off a little bit about the air. Is it very cold? Is it very cold? No, it's I think at the back. Let me check. Is it cold? Let me see if I can control anything here. There doesn't seem to be any control, unfortunately. Seems to be nothing hidden. Sorry, I don't know how to control the room. This AV thing. See? No. These are all lights. So this is all light, so I can't really control. Sorry about that. Sorry for that. Sorry about this part. Oh, okay. Everyone knows, almost everyone knows Monday. And the weather is sunny, yes, but very soon tomorrow will be bad, right? Principal accounting. No, it's principal accounting, not principal accounting. So make sure that we are not doing accounting. Permutation about order, yeah. Care orders, 6P2. Many ways to do things. Yes, that's true. But no one write how to take pictures, right? Because that is a very important part. So the speed is okay. You can follow, that's good. Any jokes? Let me see. No. Typhoon holidays. Let me guess. This is same. Is it going to be the same thing? I got spammed by the same thing. Let's see. Oh, I can't. Why? Let's see if it's something. What does that mean? Is it something special? No, not this one. What is that guy? What's supposed to be?
Super Idol 的笑容都没你的甜，8月9日的阳光都没你耀眼，热爱105度的你，滴滴青春的蒸馏水。
So what does that mean? Is it meme? So what does that mean? Oh, okay, I see. So maybe just, I guess you want to pour the water on me, I guess. That is, but don't be violent, right? We are very peaceful society. It's not Thailand, so no need to pour water on me for good luck. Are you happy? Yeah, as I told you, not very happy. If you take care of kid, then it's not very fun. But I'm glad that you are happy at holiday. Yeah. So, but when I was kid, it's a good thing because when holiday comes in, then people come out and play mahjong. We're happy. You can hear the mahjong sound and then eat hot pot, right? Because when typhoon, then you eat hot pot. So usually it's a good time for have fun as a kid. But now let's finish the this very last part is what we call the combination. And combination is like you take the object out, but the order doesn't matter. Okay. So it's just like you take the R object out of n, then you just divide it by n factorial. Why? Because you take R out of n, but R itself can reorder them, right? So R is NP, RPR, right? Just take them divided by them, then just what you get is NCR, right? So it's important sometimes we take things out, but you don't really care about the order, right? Just like the example like this. This is again motivated by my experience when I was a student. Okay, this is I think that one is NA canteen. This is CC canteen. They still serve that, right? And now in the canteen down the road there, right? You know they have they serve the free dishes rice, right? You can call 3 different dishes and combine, mix and match, right? That is one of the least expensive thing. But this is the most least expensive food in the canteen, okay? And in local, they call it Tui Fan. So it's like, when you eat it, it's like, when you have money, you eat this one. So what we're going to do is you order the rice and noodle, okay? And then you can order one dishes as sausage, or the spam, the ham, or egg, and you have 2 sauces, black and white. And when I was a student, it's like $10. Okay. And now students tell me it's like $17. I mean, although still a little much more expensive than old days, but still the least expensive in the canteen. So the question is, right? You earn money, then what can you do, right? How many times you can do it, right? And this is the food you eat at the end of the month, right? Because at the beginning of the month, you have a lot of money to spend, but at the end, you don't have much money. That's how you do. So you have two choices of rice, okay? And the dishes, you can see 2 or 4 dishes, right? The question is whether you use the permutation or combination. The question is the plate, okay? I guess you put the ham on the one side, egg on the other. Doesn't really matter, you swap the order, left and right, right? So in that case, if you don't care, then it's 4C2. If you care whether what is left, what's right, which I think it's crazy, but if you care about this, whether the milk, the egg is on the right-hand side, the ham is on the left-hand side, if you care about that, right, then you use P, but I don't think I care. So it's 4C2, and you 2 different sauces. That's what I get. It's 24, okay? Almost a month, right? Except Sunday, you maybe go to somewhere else to eat something good, but this is what I used to have when I was a student. At least in the first year, I don't have much money. Okay? And after that, I have some intern, I get some money, so I have more choices. But before I do anything, this is very useful. So let me at the end talk about an application of the combination. And this we'll be using this in the next 2 classes later, okay? Yeah, if 2 weeks later, okay? 1 or 2 weeks later, depends on how typhoon goes, but so this is a problem of posing coins, okay? And if you total a coin 4 times, how likely you get exactly tail, okay? So if you really don't like the math, right? The thing is you can draw a tree diagram, right? The first toast, you can have head or tail, right? And the second one, you can again have head or tail, right? And the third one, again, you have head or tail, okay? And do the same. And you can see each time you have two choices, right? You do 4 times. So it's 2 raised to the power 4, which is 16 outcome, right? 16 outcome. And the question is asking, because each one is equal likely, right? Asking how many of them have exactly 2 tails. Exactly 2 tails. So how can you do that? Of course, what you do is you just count the number, then you're done, right? 16 is also doable, right? 16, right? But what happens if you have more, right? We want to do it systematically without doing counting one by one, right? Because we're not kindergarten student, right? So we want to do things more systematically. How are we going to do that? Is there any way we can do it systematically? Okay. So you just write that down. If suppose I do it, it's just like we write down the result is head, 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 right? Which will be, look at the tree diagram, the first one, head, 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 right? And the second one will be head, 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 tail, right? If you write it this way, it will be head, 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 tail, right? The third one will be head, head, tail, head, right? Because this guy, right? Head, head, tail, head, and head, head, tail, tail, right? And go on will be head, head, tail, tail, and so on, right? Until you get tail, 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 16 of them, right? So is there any way to represent by combination idea? Okay? Is there any way to do it? Now remember, combination or permutation is like you have how many balls you're going to draw, right? Your balls and draw things out. So how can we change this to ball idea? You can consider this. Let's have 4 balls. 1, 2, 3, 4. Okay. Ball number 1. Is it talking about head or tail? Let me see. Let me go back to the question. We're counting tail. Okay. So if that ball is being drawn, that slot will be a tail. For example, if I draw no ball, which means this is the case. If I draw only tail, I draw ball number 4, that will be this case. What will be this case if I draw number ball 3 and number ball 4 here? Okay. For this case, I draw all 4 balls. Okay. So I connect this head tail to what kind of ball I'm drawing. Okay. If I have tail, 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 means I draw all 4 balls. If I have head, 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 tail, I only draw ball number 4. If I have head, 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 means I draw nothing. I draw no ball. Okay. If I have head, head, tail, tail. Oh, sorry. They say that's why you're puzzled, because I have number 3 here, and this is 3 and 4, right? So if I have head, head, tail, tail, I have draw 4 and 3 and 4. Okay. If I have head, head, tail, head, I have 3. I have head, head, tail, tail, I have 3 and 4. Okay. So that means that this result can be considered as how I draw the ball. Okay. That means that exactly 2 tail is just I have 4 balls, I draw 2 of them. Okay. And the order doesn't matter, right? 3 and 4 is same as 4 and 3. Right? So that means that how many ways of tail is exactly 4C2, right? And 4C2 is given by 4 factorial, 2 factorial, 4 minus 2 factorial, or 3 times 3, 4 times 3, 2 times 1. So this is 12 over 2, which is 6. So there's 6 ways to do it. Okay. You can draw like, say, suppose why 6 way? Because you only want 2 tail, right? So it can be, the 2 tail can be, you draw ball number 1, 2, num 3, 1, 4, right? 2, 3, 2, 4, and 3, 4, which means this is like tail, tail, head, head, right? And this is tail, head, tail, head, and this is head, sorry, this is tail, head, head, tail, and this is head, tail, tail, head, right? 2, 3, and 2, 4, right? And head, tail, head, tail, and this is head, head, tail, tail. 6 hour. So this is how you convert this to this, right? Because you draw 4, out of 4 balls, you draw 2 of them. There's only all possible cases, right? And this how you connect them. This how why this is a 4C2, and total will be 16, right? So the probability is 6 over 16, right? Don't worry, you will see the same thing in the assignment, and also when we talk about next set of slides, binomial distribution. So this is the basic thing there when you consider the 2 outcomes. So later you will see it's called, we will talk about this in what we call binomial distribution. That one we will talk about this again. It's exactly taking account their success or failure. So don't worry. This is something that we will do it again very soon. But do remind that we have 2 outcomes each time, right? Head or tail. And to count how many number of heads, okay? Then actually it's just simply the combination. Okay, just the thing I want to remind you. Okay, if we have something and then count how many of them, and then we can use a combination. Okay? If you don't care about things happen in the order, only care about how many head we have or how many tail we have. Combination is the thing we do. Okay, this is something you have to remember because we will do it again. So don't worry. But you will do it the same question again. Maybe the assignment will ask you to do the same question, but say with 5 tails, with 5 cons, you do 3 tails, something like that. Okay, so you do it again. So don't worry. Is that okay? So we are almost done with topic 3, except the very last slide, which I'm not going to do in Excel, but just telling you how can you calculate from Excel. Because factorial is just FAC fact. Permutation is just permute. And combination, so combine. Okay, that's the only thing you need to know. But there's nothing very special because if you learn math, there's a calculator, you can already inside your calculator there. Okay, so just for the sake of convenience, I show you how we do in Excel. Is there a question before we proceed? Because we're done probability, so that's the end of the probability. 87 slide, long way, but I hope that you're okay. Because after that, we go into more probability. Although we call random variable, there is more probability. Is that okay? This is basic probability. So we're lucky that we are not doing math probability. So actually our life is not that difficult. If you ever taken probability from stat department, then you will regret what you have done in the last life, that maybe you destroy the world. You can try. You can try to do those questions. You scratch your head and say, why is wrong? Or it's so tricky, the questions. But anyway, lucky that we are in B school, so we don't have to deal with those tricky questions. So random variable, okay? So what are we doing in the random variable? As I said, this is a more probability, right? So what we're doing random variable, okay? So I don't know whether you learn this term, but what is random variable? Do you know? Do you know what's this? Do you know what's random variable? Do you know? Or anyone knows any random variable? Okay. It's very tempting. Random variable is a variable that's random, right? Variable is random. And office is wrong answer, because I remember I took this 2001 and 2021, and after that I took a stat in the B school, and then after that I go to take the stat in the stat department. The first class, the stat teacher asked this question: What's random variable? Of course, everyone say variables are random. I said, wrong. Where do you learn statistics? But anyway, I didn't say from preschool, but anyway. So what is the random variable? So random variable is even easier. Random variable is nothing about randomness, not even about variable. Random variable just you give a label to outcomes. That's it. The label is number. You give number to outcome. That's it. Nothing random, nothing variable. Why call random? I don't know. I mean, just because it's a you give a number to the outcome. That's it. Okay. Suppose a total say con 10 times. Okay. The sample space is head, tail, tail, head, tail, head with like very large, right? 2 to the power 10, right? Because each one you have 2 to the power 10, right? It's very complicated. And sometimes you don't really care about how the head or tail appears, right? You care about number of head, number of tail, right? In that case, if you total 10 times, number of head is just from 0 to 10, only 11, right? Compared to 2 to the power 10, which is 1024, right? To the power 10, right? So that means that if you don't care about how the outcomes sequence, rather you care about number of head, right? Then it's much easier, right? And if you can measure something in a way that you don't really care about the whole realization, or you can simplify things, then that's random variable, right? Because we don't care about how head, tail, head, right? But we care about number of head instead of what it realized, right? You put a number on the outcome, right? So suppose you have 2 outcomes. Let's give example first before we go into detail. Okay? Why we talk about? Give example. So this case, head or tail, right? Instead of head or tail, we have a number of head, right? So that means that head or tail converted to 1 or 0, right? Head is 1, tail will be 0. Okay. So of course you can put any crazy number there, right? You can put head is 99, tail is -1. That's okay. That's still random variable, but it doesn't make too much sense there. We want to make some sense. We put tail is 1, so tail is 0, head is 1. That means that x is number of head. Okay. Then our life will be much easier, right? Because this is what we call random variable. You give me outcome in sample space, I give the numbers. Okay. And the other example is head, tail, tail, because you toast con twice. Okay. Suppose we don't really care about how we realize, but number of heads. Why you care about that? Because maybe you just care about, say, is you're betting, right? Only the head matters, right? Or you care about head or tail. Maybe head is you are the restaurant. Head may be a rich customer comes in. Tail may be a poor customer come in. You care about a high spending customer, right? You don't care about whether 2 customers come in. The left table is the rich guy, the right table is a poor guy, right? You care about total spending they're doing, right? So in that case, you would care about, say, number of head, right? Head is high spending, right? So either 1, 0, or 2, right? In that case, we successfully reduced the sample space from 4 outcomes into 3, which is 0, 1, and 2, right? So if you're 10, remember, if you total the con 10 times, you have 1024 outcomes, right? 2 to the power 10. Okay. But now you have 11 because from 0 to 10. So the reduction of sample space is a lot, right? You suppose roll 1,000 times or 1 billion times, then you can't really calculate, right? But it's still doable, or at least imaginable, when you have random variable there. So the idea is, again, is number is very easy to deal with. Okay. Instead of looking at head, tail, head, is not a number there. And the number actually something we can have some meaning. As I said, there's some gambling problem. or financial thing, right? Each outcome has some money there, right? Suppose you want to head or tail, you point to head is $99, tail is $1. It's fine, right? If the guy coming in spend $99 for buying the high package, and tail maybe a cheap package, right? Then you put the number is meaningful, okay? So that is the idea there. Okay. And also turn out that this is a very natural way to do things. You will see very soon. But random variable, let me tell you the definition is a function that assign number to outcome. Okay, it's not a random variable. It's telling us this is the outcome. I give you the number. Head is 1, tail is 0, or whatever number you like, right? Maybe head is 99, tail is negative 1,000. It's also fine. Doesn't really matter at all. Just a number. Okay? Of course, you want to assign a good number there because otherwise, what you calculate is not going to be super meaningful, as we will see later. So here comes the technical part, which is not that easy to understand. This is called support of random variable. Is what kind of number you can put in the outcome. Okay. And of course, it's basically sample space, right? Sample space is what kind of outcome you can have, but support is what kind of number you can assign, right? And you may ask why we care about that. It is because whether support is infinite or finite, or what we call continuous or discrete, will be very different. You may ask why we have to care about what kind of number we can put in. The reason is for discrete, you can use the math in your high school, no problem, very simple. For continuous, high school math is not enough. You need calculus. You need to talk about limit, you talk about integration or differentiation. But luckily, our class doesn't require any calculus. And the intuition or the meaning or the idea that from discrete will carry to the continuous. So that will be fine, okay? And probably ask, well, the world is discrete, why we need continuous? Because although the math is more complicated, okay, the result is cleaner in the continuous. So that's why we still want to use continuous as approximation to something that you will see. Okay, bell curve is a continuous. So many things we learn actually continuous. But we develop our intuition from a discrete case. Okay, let me talk about discrete. Discrete is something you get finite, the support, right? So something like how many people will arrive today, right? It's 1, 2, 3, 4, 5, right? And this is something that is very natural. You assign integer to this outcome, right? Let me see the example. I have 2 examples here. We have set the toss a coin, right? Number of coin is a number of head is head or tail. What's the number of them? Is 1 or 0, right? And you have 4 outcomes, right? This is how we map, right? Head is 2, head tail is 1 because you count how many number of head, right? And tail will be 0, right? And you can see this is on the right hand side, right? Can be pointed by multiple outcomes. Why? That's the main thing, because I want to make our life easier, right? Because if still the same number, usually there's no gain from doing it, right? Because as I said, the sample space can be very complicated, right? Because the world is very complicated. But we can only measure, or we can see is the right-hand side, right? We can model, we can think in this way, but what we observe can be only this way, right? This is from theory. We can think about things work in this way in our toy world or the things that in the paper, but what we measure is the right-hand side. Right? Because suppose you can toss many coins, but this is what you observe. Right? As I said, I mean, that is what I said then already. So continuous means there are many support as infinite number, means that usually means any 2 value you pick, you take the mean, or any value between is admittable. Right? For example, temperature. Suppose temperature is 35 and 36, right? And any number between them is also middle, right? Maybe 35.5 is also okay, right? And 35.5 to 30 is 35, 25 is also there, right? Anything in between, pick any two numbers. Anything in between is admissible, is continuous, right? Look at stop price, right? Everything is in the middle is also there, right? Temperature or everything you measure with financial data, usually continuous is the right approach, right? Right? Say temperature, right? And if you learn physics, you know the lowest temperature you can go is when everything freezes, right? The atom freeze. Atom freeze at the negative 12, 20, 30, 70, called absolute zero, right? At that point, atom is not moving at all. So it's no one can reach there, but this is the in theory, right? So that would be continuous random variable. Okay. And this means that this notation means sample space is any number in the real number such that the number is more than or equal to this number. So you just like it's just the number line there, right? Negative 273.15 is all this number. Okay. So continuous because you pick anything there, right? Pick a number here and pick a number here. Anything in between is also allowed, right? So that means that you cannot count it, right? And similarly, you have the stock market index, right? And one interestingly, price cannot go be negative, right? So the stop price is anything from 0 to infinity. So anything is unbounded, right? Anything you can go, right? So that is the idea, okay? Continuous. As I said, we will talk about continuous, I think 2 weeks later. In this 2 weeks or 1.5, we focus on discrete, okay? And for discrete, we'll do it in very detail. For continuous, we just very short, okay? Because we don't talk about math, right? But all the math result from discrete will actually carry to continuous, so don't worry about that. I mean, we don't do any proof. We don't even show any formula. Just show you the result and some graphical analysis. So as I said, discrete, you can use high school tools. Continuous require calculus, okay, to do it formally. But we are not stat class, so don't worry about that. You will cry when you actually go to stat department because they will do something amazingly difficult. Okay, but we're happy class, right? So don't worry about this. Happy business school, so happy. So discrete random variable. Okay, so let us start the following. Okay, when we random variable, right? Is the definition is we give number to outcome. Remember, right? Give number to outcome. So, but it doesn't end there, right? We want to say, okay, for each number, we want to know the probability, right? Because when we know each number, what probability is, then we're done, right? Because the probability in the original case is for each, remember probabilities, you give me the outcome or the event, I give you the probability. Let me remind you this, okay? Because that is very important. Because probability, in our definition, is not a number. Our definition of probability is a function. It's a function that map event to number. You tell me your event, I give you a number, right? Probability A is 1/2, and so on and so forth, right? Maybe I should draw a picture there because that would be helpful. Okay. So let me maybe draw a picture because I think that would be a little bit helpful. Okay. So remember what we do is head or tail, suppose the simplest case, right? Random variable tell us this is 1, this is 0. Okay. And probability tell us that, say, this is 1/2, and this is 1/2, right? So that is what we learned. The red one is learned last class with how we assign to a probability, right? Just based on data, based on engineering knowledge, based on whatever, right? Okay. And of course, the next question would be, okay, now we instead looking at this original sample space, look at the random variable, right? You want to look at what number we will associate the probability here, right? It must be coming from here as well, right? Right? It should be this. I should tell me this is to map to 1/2. And this should give me 1/2. Right? Should be. Maybe I should do this. This map to 1/2. This map to 1/2. Okay. So for each number in the support of the random variable, each number on the random variable, I would need to tell me what is the probability of that number. So that is 1/2, 1/2. So this is called the first one we learned is called PMF, or sometimes called PF, is probability function or probability mass function. That clear? Is you give me a number, I give you the probability. Okay. Example, don't worry, it's very trivial. It's very simple, so don't worry about that. It's not something difficult. So you see this example will be, once you see this version, head or tail. So suppose X is number of head, okay? So head is mapped to 1, tail is, so head or tail, and our X is X, H is 1, tail is 0. So that is what it means here. Okay, and we know this is going to be probability of H is 1/2, and probability is tail is 1/2, right? So that means that the probability of 1 is 1/2. The probability of 0 is 1/2. Okay, and some of you actually ask me why I use PR probability, because I have to reserve P for the probability function. Okay, P is a function because you give me a number, I give you a probability. Okay, that's why they call probability function, or because of this is a physics, is a mass. Later you will see why they call mass, because the content is called density. But anyway, mass means that you give me a number, I give you the probability thing. Okay, probably P of 0 is probably X equal to 0, which means probably its tail is 1/2, right? So that is the case. Is that okay? Now, since we still have time, so we can go to a more fun, another one. Okay, I'll tell you this one, then I will stop. Okay, of course I'll tell you this is the last concept talk of today. You can take it with you with the typhoon. So this is the cumulative distribution function, CDF. Okay, it's nothing but adding up the P. Okay, it's adding up the P. Adding up the P. F of X, the big F, is adding up all the P that less than or below it. So it's asking the probability that the random variable is less than or equal to that value. Okay. It's not intuitive, but there's some mathematical reason why you want this one. Okay. And I'm not going to elaborate today, but I'll just tell you what it is first. Okay. So let's look at this question. Look at this example. So I have a sample space, head or tail. Okay. I roll only once. Okay. So I don't remember head, same as before. So this part's still the same, right? So just remember, I have head or tail here. Okay. and head or tail are mapped to 1 and 0, okay? And we know equally likely. So P of 0 is 1/2, P of 1 is 1/2, okay? So how can you get F? F is asking go up, okay? This number is gonna P, but L before, okay? So 1/2 go up, this go up, 0 is 1/2, then you're done. But for this one, you go up and add everything before, because asking what is a value less than or equal to that one. You go up and go left. And that's it. That's what I said. Okay? So in order to make sure that you see what's going on, we go to kindergarten class where we are stacking Legos or logs. Okay? This one, we know already how to do P, right? Because this is actually head, right? This is tail, right? One is head and tail is 0, right? So the probability that equal to tail or head is 1/2 and 1/2, right? I hope you agree that, right? There's something, if fair con must be this. Of course, if you say the con is unfair, then you can make the red lower or higher, depends on what you need, but need not be equal, okay? Need not be equal. If the con is unfair, say head is more likely, right? Then head can be, say, 3/4, tail can be 1/4, right? It's okay. But I make it easier, is equal. It can be unfair, okay? Need not be fair. But now what is F? What is CDF? Cumulative adding up itself and before, okay? It's the kindergarten problem. You have yourself, no problem. From the beginning, the first one, the first F must be same as the first P because you add up yourself and before, right? So the same thing. But the second one is different. The second one is you're doing Lego, as I said. You stack what is before you. Okay, you stack together. That's it. So because asking what is F, big F of X is asking you what's the probability that you observe this value or below. Okay, and in that case is how is the probability that you see head or tail, right? It's either 1 or 0, right? That means head or tail, which is must be 1. That's why it's 1 over there. Is that clear? So that's why if you stack, you from here to here. If you unstack it, you can go from here to here, right? So these two are same way to see the problem. Either you can go from left to right or right to left. Okay, you ask me why we do this, okay? This is natural. This is unnatural, right? Why we have to stack things? Good question. Because when we learn continuous random variable, this is the only meaningful way to describe. This is not. Why? Because what's probability? You guess a number from 0 to 1, right? Then too many numbers to write, right? It's not feasible to do this because later you will see the probability of getting a particular number is 0. Suppose you draw a number from 0 to 1, any number, okay? If the computer is randomly draw a number, any particular number comes in will be probably 0. Right? Imagine like this, right? I want to flow this, right? Then I hit a particular point, will be almost 0, right? I have pistol, right? Hit some particular point. Unless I am a super Olympic guy, right? Likely that I cannot hit perfectly, right? It means that probability of equal to a particular number in a continuous random variable case is 0. So this is not feasible to define easily, okay? But this can always define easily. So that's why when continuous, we'll talk about the CDF all the time, okay? Of course, you can define something similar like this, but this is the most fundamental one when it continues. For discrete, this is the most fundamental, okay? But I let you know that these two are the same thing, okay? You can go one or the other, okay? If you learn calculus, actually this is from here to here is called integration. From here to here is differentiation, but I'm not going to go to detail on this, okay? But do note that they are just stacking on the P, give you the big F. Okay, stacking together the P's, we get the big F. And you are cutting, comparing, differentiation or the cutting, take a difference, will give you the big P, okay? So I don't want to continue, but we will see more example later, okay? So although 1 minute, but I guess we can enjoy the typhoon holiday. You enjoy, but I will be suffering. So I see you. The assignment will be released today later. Have a nice day.